In this demonstration, we will be looking at the main differences between the buffer and the store object in Facts. In this simple model, we have two parts, part A and part B. They are created in a source, 3 at a time, like this. 3 part A and 3 part B, and then over again. They go through either a buffer, capacity of 6 and processing time 0, or through a store object. Then we process part A in OPA and part B in OPB before they leave the model. Using the selection object, we are able to add both a buffer and a store at the same location in our model. It makes it easy to switch which one is the active one. The buffer is similar to a conveyor belt. It's strictly FIFO. It means parts are not allowed to overtake each other. And also that it makes no sense to assign different processing time for parts in the buffer. So only the constant process time is allowed for buffers. The store, on the other hand, is more similar to parallel operations. Parts are allowed to overtake each other, and it can have, as we will see, an impact on the throughput of your model. So let's start by using a buffer. You can see here, buffer is the active choice in the selection. So start the animation. So there are 3 parts A, 3 parts B, and one of the machines being idle due to only being allowed to process one of the parts. And this is due to the buffer being strictly FIFO. Parts are not allowed to overtake each other. And if we switch back to the store, we can see that we have A and B being processed simultaneously all the time, due to the fact that the parts are allowed to overtake each other here. One of the drawbacks of this is that simulation-wise, it will generate a lot of events, so the simulation can be slower due to this. So the store object should be used sparsely and only when actually needed. Seen in another way, we can go back, selecting the buffer again, and we run the complete experiment and look at the throughput. We have 90 parts per hour produced, and the operations are utilized 75% of the time. Whereas if we go back and select the store object and run the same, we see that we increase our throughput to 120 parts per hour, and utilization of the operations are 100%. In this demonstration, we looked at the differences between the buffer and the store object in Facts. We saw that using a buffer and its FIFO behavior caused the operations to be utilized less, and in turn giving us a lower throughput of 90 parts per hour compared to using a store where we got 120 parts per hour. A store can be very useful for this scenario where we have parallel objects after the store, But it can also be very useful when doing assemblies and you need several parts available at the same time.